All right, hey everyone. So today we're going to be looking at Gemma-3-4B-IT. That means the Gemma 3 model that was just released last week on March 12th. Today is March 20th. They've already made several updates since. The 4 billion parameter version of it, it'll fit on basically any hardware that you have that's modern. And then the IT version, meaning instruction trained. So when we talk to it, it'll be pretty good at having conversations back and forth with us. The other option is the PT version, which we can use later for fine-tuning or other examples. But if you just want an out-of-the-box model that you can use, that you can run on consumer hardware, that will give you good text-to-text or image plus text to text output, meaning you can put in an image, ask it questions about that image, and it'll give you a text-based response. This is about as good as it gets. So let's dive in and take a look. All right, and now let's talk about why Gemini 3 4B-IT is useful. Why did we pick this one? Well, because it's super accessible. You can take it on Hugging Face, download it, use it right away. You can integrate it into chatbots. You can use it to analyze pictures that you take. It's pretty versatile, and it's very accessible. You can run it on basically any computer, any consumer hardware. If you have a graphics card, it'll speed things up quite a bit. The model parameter sizes aren't so large that you can't run it on some other hosts. The basic back of the napkin math is 4 billion parameters, BF16 precision, which means 16 bits, which means 2 bytes, 2 times 4 billion. You're looking at like 8 gigabytes of memory in use. Basically any of the modern M1 MacBooks that you have, M2, M3, M4, they're going to have 16 to 32 to 64 gigabytes of VRAM available for you, or shared memory. That means that this model will easily fit into memory. You can easily use it for a multitude of use cases offline or online. Also smaller model sizes, if you do choose to run it in the cloud, which we have this Docker image, it's going to be a little bit cheaper than running a large model. You won't have to request as many GPUs and you'll get similar performance. It's modern, it's usable, it's safe. Google does a really good job of making sure that their models don't print out questionable outputs. So you can feel pretty confident that even out of the box, things are in good shape. All right, so now we're going to take a look at the actual example that we prepared today on the usage of Gemma-3 4B-IT. Okay, so starting with the Docker file. If you want to use CUDA, you're going to need a CUDA-based Docker image. So I'm using Podman, same thing, just open source. Here we have NVIDIA, CUDA, and then I went to the NVIDIA website and did a little searching around. We have the development Ubuntu 22.04 version, where it's version 12.4.1. All right, fine. We're going to copy all the code that we have over here in the Gemma directory and install Python, install Git, install virtual environments, set them up, install the requirements. And then down here we have this command we're going to run, Python 3 demo.py, and then our prompt is, I'm trying to decide whether to go on a vacation to California or Florida. Help me decide by comparing the benefits and drawbacks of each. Let's add it. All right. And then we can look at what are the requirements for this project. Well, we got very few requirements. Torch, transformers, accelerate, Hugging Face hub so we can log in, Pillow so we can look at images. It's a requirement for Gemma 3, and then arg parse. Okay. And how are we going to run this? Well, we have a simple bash script that we can run that builds the container and then runs it. All right, and now we're going to look at the actual code itself. So let's start up our screen record for you here. Okay, and what do we have? Well, arg parse, torch, Hugging Face hub so you can log in. This is a key part. You will not have this if you just have the regular transformers library. As you can see over here in the Docker file, we were going to Git to get this transformers version 4.49.0-Gemma-3. It's a mouthful, but basically You have to install it this way, otherwise you won't have access to this Gemma 3. It doesn't exist yet. This model's only been out for 8 days as of the time of this recording on March 20th. So you're going to have to get something specific to it. All right, and then second problem we run into here, you need to get access to the model, which means that you need to go to huggingface.co, go to the Gemma 3 model, I'll leave the link in the description, and you need to request access. You need to enter in your email, that's fine. Once you get access, that means that you will need then to log in. So here we have this set up where you can see up here, to log into Hugging Face for access, you need to put in the key that they give you. I just put in a placeholder here, and you're going to store it in your Podman secret. You're going to create a Hugging Face token. Then you're going to attach that when you run and build, as you can see here in the deploy, where when you run it, you're going to attach this secret, and that'll make a new folder available, which will be this run secrets folder with the Hugging Face token in it, where you'll read it in and then pass that into a login function through Hugging Face Hub. And so you do need internet connectivity to run this model. Once you get that though, you can run it, and that's what worked out here. So here's the name of it. You can search that out if you want. Google/Gemma-3-4B-IT. We're declaring that we're going to run it through CUDA. If you're using a Mac, some of these things will change, like the Docker image. Also, you're going to be changing this CUDA to MPS if you have an M series Mac, because MPS means metal performance sharding. I think that's what it stands for, because it uses the metal toolkit or metal kit, and that's what you're going to use instead of CUDA. But we're using CUDA because we have a desktop behind me. So then you're going to take the model, you're going to run it through eval. That means that you're not setting it up for future training, you're just going to use it as is. You're going to take messages, I'm just saying it's a helpful assistant. This is pretty standard boilerplate text. And then we're going to pass in the prompt that's passed in from here, and we pass in through the arguments. So next thing, it's going to call run. This is our entry point into the code, where we're going to build inputs. This is straight from the documentation. We are going to take the messages that we passed in up here, that we created up here, and we're going to generate new prompt, tokenize it, return a dictionary. That's going to get passed in through the device, which is going to be your CUDA device if you're doing the same thing as me. You want the same precision as the actual model itself, and then that's going to get passed in here. We need the length because we're going to end up truncating some of this. But yeah, so you generate it. It'll generate 2048 output, and then here there's a bunch of stuff to standard, instantiate it, create arguments, parse them, pass them in, and then run it. So this is going to take a few minutes, but as you can see, the way I have it set up is I SSH'd into my server. If you need help setting up the server, we do have this Podman that tells you how to set up all the different pieces, where you're installing basically the most modern Podman. One of the issues I ran into is that if you just go to Linux right now and download Podman, it's going to be like 4.9 on Linux Mint if I go through the regular app manager. But so here, this is building from source, and that uses 5.5, which means you don't need to use other NVIDIA toolkits. You just need the it was NCT, NVIDIA Container Toolkit. Okay. So then we're going to go back here to the demo, and we can run it. So I am SSH'd into my remote server. Pretty simple. It's on my local network. Only I can get to it. I'm going to CD into this once I copy over the code that I want. You guys should know how to copy over code if you even want to do it that way. I have the base image here, and then this deployment script will handle building and running. So all we got to do is deploy and run. And I'm going to let that run for a little while. It's going to take a few minutes, so I'll record it, and you guys can see how it goes, but I'll be back. And we're back. So we can take a look at this and see the output. All right, so the outputs we got here, it's all in English. Next we'll do a multilingual setting. So let's tackle this California versus Florida vacation decision. Both are fantastic destinations, but they offer different experiences. And then you can see that it goes through, tells you about California, lists out the benefits and the drawbacks. Then you have Florida, lists out the benefits and the drawbacks, and it gives you a little chart here, a little ASCII chart, maybe not perfectly formatted, But you can see that it goes to an interactive prompt where if you wanted to keep this running, and we can show that in another video if anybody's interested, you could then allow it to keep the context and continue running. So now let's take the same file that we have here and we can show you a multilingual output. Okay, and now we're going to use the multilingual output. So let's see. Сами лучшие места для отдыха в России. Okay, so now we're just going to type in where are the best places for vacationing in Russia. And when we run this, we should get a multilingual output back, or rather we should get a Russian output back, and this is just showcasing that these models are indeed multilingual out of the box. So we talked about they can support 35 languages out of the box, up to, I think it was 140 pre-trained, 190 pre-trained, I don't remember. So anyway, basically anything you're going to work with, you can use it out of the box as is. So I'm going to let this run and we'll come back in a minute and show you the results. All right, and now let's take a look at some of the results. So first time I ran it, it did fail. I had to add in a new parameter up here, which just says attention implementation equals eager. Yeah, so basically the reason we had to do that is because our PyTorch and drivers didn't resolve any issues. So that's fine. Anyway, so let's see what it said. It said basically in Russia, you should go check out the Republic of Altai, Kamchatka, Lake Baikal, Karelia, Sochi. If you want to go to the cities, you should check out St. Petersburg, Moscow, bunch of different places. So it's it's not very specific, but it once again allows you to come down here and see how you want to converse with it. It asks you, what do you want to do? Do you want to go out in nature? Do you want to go see places with like the Kremlin and Red Square? Or do you want to go out and basically see places with like lakes and rivers and places like that? So pretty interesting, really incredible. This wasn't possible just a little while ago. This is a big leap in technology in that now we can, with no fine tuning, no training, like you saw, we just downloaded this right out of the box. We can now just download a model, send it a prompt, and get back English or Russian, or I imagine German, Spanish, Chinese, anything like that, responses. So it's quite a leap forward and another big win for Gemma. Okay, and then you can kind of see that we have a GitHub here as well, github.com/solutionai, and then AI model tutorials. This is a public repo. So yeah, so you can go here and check it out. It should be under here, text to text, Gemma, and here's our Docker file. Okay, so you can see all the codes there. All right, and so that's all we got on Gemma-3-4B-IT. At this point, you should understand how to use it, when to use it, where you can get it. Basically, just take this Docker image. We'll leave a link in the code, link in the description for the GitHub code, and you'll be able to run it using Docker. You can run it on a server or not. This is obviously optimized for CUDA, but now you understand. Pick a different image, make some adjustments in the class init file, and you can run it without it. So if you want to run it with Metal Performance Sharding, because you're using a MacBook M4, M3, M2, M1, then go ahead and just swap out CUDA for MPS. and you'll also have hardware acceleration that way. So this should be a pretty quick and easy way to use it. Pretty scalable way too if you decide that you want to run it in the cloud on something like Cloud Run. You have multiple containers that want to take advantage of it. So if you have any questions, feel free, reach out, put comments, like and subscribe, and see you in the next one.